Hello everyone, welcome to the Software Testing by JP channel. In this session, we will discuss the remaining topics of Session 2, including the Spiral model, V model, and more. If you are new to the channel or haven't subscribed yet, and you want to support me, please subscribe to the channel and hit the bell icon for future video upload updates. We will start today's session. The next SDLC model is the Spiral model. To understand this, I have copied a diagram here. We will use this diagram to learn the spiral model. In this diagram, we have 4 parts: planning, risk analysis, design, and evaluation. In these 4 parts, all SDLC stages will be covered. In the planning phase, we have requirement gathering, cost estimation, and resource allocation. All of these are part of the planning process. After that, we move to the risk analysis phase where the strengths and weaknesses of the project are covered. Following that, we enter the design stage where coding, internal testing, and deployment are addressed. Finally, we have the evaluation phase. Once the application is deployed on the client side, we gather feedback, which constitutes our evaluation part. Say we got 10 requirements from the customer. Once we get the requirements, the planning stage will be started. So, we do the planning for those 10 requirements. After that, we do risk analysis, and then we move on to the design phase. In the design part, we do coding, testing, and deployment. Once all this is done, we will get feedback from the customer. So, here, we deployed our first prototype with those 10 requirements. After receiving feedback, the customer provided some more requirements. For example, let's take 10 additional requirements. The same steps will start repeating, like planning for those 10 requirements, conducting risk analysis, designing, coding, testing, and deployment. Once all this is done, in the evaluation part, the customer will provide feedback. After feedback, our second prototype is ready. In the spiral model, we repeat all the stages whenever we get new requirements. This cycle keeps on repeating, and the final product will be ready. The final product will be ready once the customer stops giving new requirements. I hope now you people understood how the stages are accommodated in the spiral model. Now, let's explore the advantages and disadvantages of the spiral model. Before that, let's review the definition of the spiral model. The spiral model is iterative in nature and is also referred to as the version control model. The term iterative is used because, for instance, in our first iteration with 10 requirements, we released prototype model 1, marking the first version of the software. After the initial evaluation, we received 10 more requirements, and for those, we released prototype 2. Hence, prototype 2 can be considered the second version of the product. This is why the spiral model is also known as the version control model. The spiral model allows for incremental releases of the product or incremental refinement through each iteration around the spiral. In other words, something new is implemented in every cycle, leading to the refinement of the product with each iteration. It effectively overcomes the drawbacks of the waterfall model, helping to address the limitations associated with it. The spiral model is particularly well suited for large projects or projects where there is a significant dependency between modules. It proves beneficial in scenarios where dependencies among different parts of the project need to be managed effectively. Now, let's explore the advantages of the spiral model. The first advantage is that it allows requirement changes. It is also suitable for large and complicated projects, as the development can be distributed into smaller parts, essentially dividing the big project into smaller, manageable modules. Another benefit is that it allows for better risk analysis, improving with every cycle. This model proves to be cost-effective due to effective risk management, allowing for easy risk mitigation and cost savings. Moving on to the disadvantages of the spiral model, it may not be suitable for small projects. In this model, the product is developed through multiple cycles, and the success of the project heavily depends on the risk analysis phase. The main emphasis of the spiral model is on risk analysis, determining the project's success. The better the risk analysis, the more successful the project will be. One notable disadvantage is the absence of testing in the requirement and design phases. Here, the requirement and design phases aren't subjected to testing, which may lead to potential issues later in the development process. In summary, the spiral model offers advantages such as adaptability to requirement changes, suitability for large projects, and effective risk analysis. However, it may not be ideal for small projects, and its success is contingent on the thoroughness of the risk analysis phase. Additionally, the lack of testing in the early phases is a notable. After the spiral model, we have the VNV model, where VNV stand for verification and validation. In this model, testing occurs at every stage. Let's delve into the details using this diagram. Firstly, we see CRS, which stands for Customer Requirement Specification, also known as BRS, Business Requirement Specification. BRS is created by a separate non-technical business team after discussions with the customer. The business analyst, BA, is responsible for crafting the BRS document in simple English language, devoid of technical terms. It is important to note that BRS undergoes testing, typically in the form of walkthroughs, reviews, or inspections. This type of testing, conducted on documents, is referred to as static testing. BRS serves as the basis for the subsequent SRS, Software Requirement Specification, document. Moving forward, the technical team, comprising QA or development teams, creates the SRS. It is a technical document, and testing and reviewing are integral parts of this stage. SRS is derived from the base document, CRS. Project managers may also contribute to creating the SRS. Once the SRS is completed, the design team generates the HLD, high-level design, document. This process follows a systematic approach, ensuring that each stage is reviewed and tested. The VNV model emphasizes thorough testing and validation at each step to enhance the quality of the final product. Following the creation of the HLD, high-level design, it undergoes review and testing, and based on this, the LLD, low-level design, document is generated. HLD focuses on big modules, while LLD breaks these down into smaller modules. Both HLD and LLD are created and reviewed by the design team. CRS, SRS, HLD, and LLD are all document types, and static testing is performed on them. Document static testing involves techniques like reviews, walkthroughs, and inspections, ensuring the quality of the documentation. Testing is a continuous process at each stage of the VNV model. Moving forward in the VNV model, based on the LLD, the coding or development team starts coding. CRS and SRS belong to the requirement gathering stage, while HLD and LLD are part of the design phase. The next phase is the coding phase, where coding is done on small modules. After coding, unit testing is performed, and this is conducted by the developer. Unit testing requires coding knowledge and falls under white box testing. Once the developer completes unit testing, the testing team takes over, conducting functional testing. Following functional testing, integration testing is performed. In functional testing, individual modules are tested, and once they are integrated, integration testing takes place. The final testing stage is system testing, which occurs after integration testing. Unit testing is carried out by the development team, while functional testing, integration testing, and system testing are conducted by the testing team. Once the QA team completes system testing, the product is deployed on the customer side. The QA team, along with the customer, conducts UAT testing, which stands for User Acceptance Testing. The testing performed by the QA team is referred to as black box testing, while the testing done by developers is called white box testing. This dynamic testing involves unit testing, functional testing, integration testing, and system testing, whereas CRS, SRS, HLD, and LLD fall under static testing. In the VNV model, the testing team is involved from the beginning, starting with the preparation of BRS or CRS. Once BRS is completed, the testing team reviews it, checking for any ambiguities, gaps, or missed requirements. If any issues are identified, the QA team highlights them. Based on the BRS, the testing team then creates the acceptance test documents. While the QA team is working on this, the development team is simultaneously working on the SRS. Both teams work in parallel, generating their respective outputs. This concurrent approach enhances efficiency for both the QA and development teams. In summary, the VNV model is a widely used and popular model in the software industry, ensuring comprehensive testing from the early stages of requirement gathering through to the final deployment on the customer side. Indeed, validation in software engineering begins once the product is prepared. It is the dynamic mechanism of testing and ensuring that the software product meets the exact needs of the customer. Unlike verification, which is focused on the process of checking documents and designs to verify if the software has been built according to requirements, validation is about confirming whether the end product is right. Validation involves checking if the software product aligns with the customer's expectations and specifications. This dynamic testing process is performed after the development phase, ensuring that the software meets the actual needs and requirements of the users. Dynamic testing is the key approach used for validation, where the software is executed, and the results are observed to validate its correctness and functionality. To summarize, verification ensures that the software is built correctly according to specifications, and it involves activities like reviews and inspections during static testing. On the other hand, validation focuses on confirming that the software product is right for the customer, and it occurs through dynamic testing after the product has been prepared. Now, let's check the advantages and disadvantages of the VNV model. The first advantage is testing starts from the initial stage itself. Compared to the waterfall model, testing begins right from the start in this model. The second advantage is the testing team will be ready with the test cases by the time developers release the software, saving a lot of time. The third advantage is testing is involved in every stage of product development. In the VNV model, testing is compulsory in every stage, leading to less or no rework. In contrast, in the waterfall model, if a bug is found in the requirement stage, it continues to affect design and other stages. This doesn't happen in the VNV model. These are some important advantages of the VNV model. Now, let's explore some disadvantages of the VNV model. The first one is the initial investment is higher because the testing team is involved right from the early stage. Testing is done in the early stage, and testing is performed in each stage, requiring hiring the testing team early, which increases costs. Additionally, development teams are also involved from the initial stage. The second disadvantage is that whenever there is a change in requirements, the same procedure continues, leading to more documentation work. Even for small changes, all stages need to be repeated. These are some of the disadvantages of the VNV model. I hope you guys understood. In this session, we learned about the Spiral and VNV model and their advantages and disadvantages. Okay, now it's time to wind up this session. We will meet in next session with new topic. If you like this video, subscribe to the channel, like the video, and share it with your friends. Also, don't forget to hit the bell icon. It will give you notifications whenever I upload a new video. Thank you, and goodbye.